Hi there, my name is Jonathan Ross. I'm an instructor for digital media, and in this lecture we're going to be taking a look at mobile development. Now I'm going to be talking about the constraints of mobile development as well as some of the technologies that are available for us to be able to create for mobile devices. So let's get started. The first thing that we have is the fact that mobile has grown at incredible rates, and I'm going to spare the video right now. You can go to the YouTube link that's here at the bottom and see if you can find it. You can probably just search for the growth of mobile as well. Now, the problem with mobile is that there's a lot of constraints with it, and that is there's a lot of problems with development. Some of the problems that we have are platforms, form factors, input mechanisms, and the rest of the stuff here, and we'll go through each individually. The first thing is platforms. Of course, we have a couple major platforms. We have the iOS devices like the iPhone, iPod Touch, and the iPad, and then we have this army of Android devices that are coming out. If you look at all the different companies that are producing Android devices, it's quite a lot of competition for Apple, in my opinion. Now, the question is, are there other competitors like RIM and Windows 7? I don't really know right now because it seems as though Apple and Android are kind of taking over, in my opinion. Now, if you look at what's happening out there, though, there is a lot of growth in the market for mobile development. This right here is showing a growth of Apple sales and Android sales. The Android is this kind of gray. The Apple is the blue at the bottom. And then the blue here at the top is all the rest of the devices or all the rest of the potential devices that could be out there. So there's a lot of growth in the entire field still to happen. Now, tablets seem to be blazing a trail right now for being the go-to thing for mobile devices. And when it comes to the Android devices, there are tons of different types of tablets. Some of them are pretty good, some of them not so good. I happen to have the ePad Transformer, and I love it. And the new one, that's the one here on the right, is coming out soon. That's called the Transformer Prime, and that has this new souped-up processor and all that kind of stuff, which I'll talk about here in a second. Now, the other thing that's happening is that inexpensive tablets are coming out. We have the the Kindle Fire, and we have the Barnes & Noble Nook, and they're both low price, inexpensive tablets, and they seem to be making quite an impact on the market for mobile devices. Now, one of the other constraints is form factors, and that is that we have every form factor you can possibly think of. You know, people want to be able to have the same content on TVs and iPads and small phones and smartphones. And if we just look at smartphones themselves, all of them have different sizes, which makes developing graphics for them quite a challenge. Now, Adobe was kind of trying to lead the way towards open screen development, meaning that the same content to fit on all the screens, but there's some problems there which we'll talk about later. Of course, the question that this problem is about is HTML5, and will HTML5 come up to save the day? And some people think yes, some people think no. Now, when it comes to input mechanisms, this is another thing which is very different on mobile devices. For years and years, we have had the mouse, which was how we'd interact with the computer. Now we're using touch events and gestures, which means that we have to be able to click on what we want, and then we'll do swiping and pinching and zooming and all sorts of stuff, and a lot of drag type things, which we don't get on regular computers. To find out more about gestures and different devices that use them, you can go to this website, gesturecons.com, that shows different gestures across lots of different types of devices and how they're implemented. Now, we also have other types of gestures, I guess. You can call them gyroscope or accelerator gestures, where we maybe tilt or wave the handset or shake the handset, or maybe bump the two together. We also have voice actions, which allow us to speak to our devices and have them do things. Siri, of course, is one of the most common ones right now on the iOS, but Vlingo and, of course, the voice actions that are on the Android operating system itself are both capable of very similar things. Now, design patterns are about how the different devices are typically built so that we know how to interact with them. And you'll know that between the Android and the iOS, we have some different design patterns for sure. Now, this particular one is about Android patterns, and we have how do you deal with a data list, or how do you get input on something? How do you deal with navigation, notifications, personalization, and screen interactions, such as flicking and zooming and all sorts of stuff. Now, you'll find that there's a lot of similarities between different devices, but you can pretty much tell what a device is. Like, I can look at that and say, well, that looks like an iPhone. This one, maybe not so sure. These two to me look kind of more like Android. So you're seeing a lot of crossover, but there also are some visual cues that you see are exactly one platform versus another. Now, it doesn't mean that you will always be stuck, because as designers are coming up with new designs for mobile devices, they're breaking some of these trends and developing new trends. The interaction style might be very similar, but the graphics might be kind of unique and stuff for each individual application. Now, feature differentiation is another major feature of, or constraint of, mobile devices. I mean, if you look at just the Androids themselves, I guess this is more than just the Androids. You've got the iPhone in here, and you've got some BlackBerry and Nokias as well. Every single one has different features about the display size and the GPS and Bluetooth and everything else. So there's a lot going on here, and so we just have to be aware of that as we're developing, so that we don't develop something that is so particular to one device that it can't work on others. Now, the problem with all this device differentiation is that everybody's suing each other for patent infringement because of these different things. Of course, everybody's suing Apple, and Apple is suing everybody else, and a few people are suing each other. So it's pretty crazy out there. Hopefully it'll be worked out in the future. Now, when it comes to available software, this is what most people interact with. They interact with the applications that are on their devices. Now, this particular chart says of October 2011 that there are 500,000 applications on the iTunes Store, and Android Market has 350,000 applications. But I'm not exactly sure if that is correct, because I've heard that they're a little bit more balanced at this point. Now, one of the things that I think is kind of interesting is that if you look at how many free applications there are on the Android platform, it's almost twice the amount of any other platform. Now, that's good and it's bad. Part of the Google mantra has always been to give out things for free, and the Apple mantra has never been that. So what happens is that there's a lot more applications on the iPhone market that are paid for, and people actually pay for them. So people tend to make more money distributing things through the Apple markets than the Android markets. Now, we also have multiple networks. The networks Verizon, Sprint, AT&T, T-Mobile. Everyone claims that they have better coverage. Everybody claims that they have better speeds. And in one city, maybe Verizon is faster than Sprint or AT&T, and in another city, AT&T will be faster than Verizon. So I think it really depends on where you are and what type of devices you have. The last thing that you can kind of see as a major constraint right now, which is really becoming less of a constraint, is actually the processing power of these. The power of mobile devices is increasing so incredibly fast. It's incredible. We have the Tegra 3, which is just coming out, which is the first mobile quad-core processor. It has a fifth core for lower power consumption. But this is the new processor, which is going to be on the Asus Transformer Prime tablet. And if you look at what it says it can do, it's absolutely amazing. So our mobile devices are getting as fast as our computers, and they are getting faster, faster than the laptops and computers are. So at some point, it seems as though mobile devices are actually going to go just as fast, if not faster, than our regular desktop computers. Now, the last major constraint are the users themselves. Now, the mobile context is kind of a term that's used to describe devices, user, technical stuff, and all of that put in together. But the most important part of this is really the users themselves. And we all know that we have very, very busy lives and they're very chaotic. And when we want to use an application, we want it to work instantaneously. And so what people have found is that mobile users have about 30 seconds that they're willing to work with an application to figure it out. And if they can't figure it out in 30 seconds, and they fail using the application, then they're probably not going to come back and try that application again. Instead, they're going to go to competing applications and see if they're better. So there are some major principles for mobile development that we should be aware of. Some of those principles are of interface design, functionality, usability, accessibility, aesthetics. We can actually put this in a little bit easier terms to say that they need to be easy to use. These applications or things that we're using on mobile devices have to be easy to use, they have to be responsive, they need to be intuitive, and they need to be visually cool or visually stimulating. So if you look at some of the applications that are winning like design awards, you'll notice that they're very simple, but they're very elegant, and they guide the user in knowing what to do. So there are lots of different ways to develop for mobile devices. If we look at the different ways, this is what I'm going to kind of go over. Native development, websites for mobile, JavaScript APIs, web apps, JavaScript app development, third-party development tools, which are like cross-platform compilers, and then Flash and Flex. The first thing is native development. There are basically two ways to develop right now. There's Objective-C for the iOS, and then there's Java for Android and BlackBerry and some others. When we look into understanding native code, it means that we have to understand some pretty major stuff. We need to be able to understand a lot about object-oriented programming and methods and variables and all sorts of stuff. Because if we look at the code that we generate in something like Xcode, it's Objective-C, and that means that it's some pretty complicated code if we take a look at it. So this is some Objective-C code. Me personally, I'm not so interested. Another one, this is Eclipse editor for Android. You can do other Java applications, but once again, it's based upon Java, which is a pretty intense language and takes a lot of learning in order to be able to get to the level to develop things like this. So Google actually came out with a tool that would kind of bridge that gap for people who are trying to use some of the native code but not know how to write it. And so they came up with this thing called Google App Inventor, which you would use these blocks and be able to actually program in Java using basically puzzle pieces in order to do so. And I think now this application is actually going over to MIT and hopefully will be developed even further. Now there are major benefits of using native code. The benefits are that you get the best performance. It is the fastest code on the devices. And you can access all device features, the gyroscope and the mapping and all sorts of stuff. Now the drawbacks of it are that it is the most complex to develop and it can only be installed as an application. So people have said, well, this isn't really what we want to do. We'd really like it to be a website. Instead of having to develop it on each phone, let's develop it on the internet and have people actually use that as an application. So this is really about websites that are optimized for mobile. Now, the question is, do you want to develop a mobile website or do you want people to access your standard website? And most of the times people want it to be a mobile website if you're using something like an iPhone or Android device. So there are a few things that we have to be able to do. We have to be able to detect the device. We also need to be able to use meta tags and set our viewports and full screen and stuff like that. We can do this with media queries, and we also need to be able to understand what touch events are. Now, with device detection, you can detect with lots of different languages, JavaScript, PHP, jQuery, and others. You can detect what type of device they have, what user agent they have, the viewport resolution, and even the orientation. For example, this is what a user agent detection is. So it says that I'm on Mozilla, Windows NT 6.1, I was using Apple WebKit, and KHTML like Gecko browser. And I think I happen to be using Chrome or something. Anyway, with device detection, here is a PHP one, which says if you're on these different devices, then say the device is mobile, and if it's mobile, let's redirect you to a different location. Another one here is redirecting with using a htaccess file, which has a rewrite rule that detects your user agent and sends you somewhere else. Here's another one that's using JavaScript, and with this one I'm detecting the user agent and just setting a class to either iPhone, iPad, Android, or desktop. So pretty simple. You can also detect orientation using JavaScript, and here's where we're updating the orientation, finding out what the orientation is, and then it gives us a number if it's 0, -90, 90, 180, and it tells us what orientation we have. And this works quite well on an iPad or an iPhone. Now, we also have mobile meta tags that we can use. Mobile meta tags do things like set our viewport to the width of our content and set the initial scale to 0. User scalable is yes, so that means that the scaler can use it. We can also detect what the density of the DPI is. This is helpful on iOS devices like the iPhone that has the I think it has twice the DPI resolution on the screen than some of the others. And we can also use meta tags in order to create icons, like homepage icons with PNG files. So it's pretty cool. Now, media queries allow us to change our CSS depending on what type of screen we're on. So the first ones that I have here are just very simple. That say, let's have a style sheet. It'll be a screen style sheet that'll work on screen. The mobile one will work on a handheld device. Here it's a little bit more complex, where what we have is screen and max device width of 480 pixels and the resolution of 163 dpi. Will send us to the mobile CSS file. So this, we have conditions in there about what the width must be. We can also do this in our CSS itself by putting in @media conditional statement sort of inside of our CSS that says that if the media is screen and the max width is 480 pix, then it will set the column to float none. Otherwise, it might have a different type of float. So we can do a lot actually with just CSS in order to make a mobile website. Now, this has kind of led towards, these ideas we've been talking about here, has led towards the ideas of responsive or adaptive design. And that is that you'll have lots of different screen resolutions and orientations here that might be accessing the same content. So we need the website to respond to that. Whoops. So there are different frameworks to do that, such as the LESS framework. And what this allows us to do is, as we scale our page, it will change our CSS so that we have different layouts. Some sample websites that we can go to are such as this, handcraftedpixels.company. And you'll see that it changes depending upon the size of viewport, which is really quite cool. So you should go to that website. Now, the last thing that we have to be aware of on a mobile device is that we're using touch events rather than just regular mouse interactions. And so there are ways to handle this and register these events. We can do it with starting them inside of a div and adding them with, let's see, a JavaScript or a number of different methods. And there's even applications or APIs for us to do that, and that actually leads us towards APIs. Now, we're not going to talk about this too in depth because this is where things get crazy. There's a JavaScript API for just about everything out there in the world. If we look at what's available, we have ones for Google Mapping, we have ones for interaction and user interface, and we have other ones for interaction and user interface. And then if we look at actually how they've grown, from 2000 up till now, there used to be just a few APIs, and all of a sudden we're into thousands of APIs that are out there for every single website that you can interact with their websites, and then of course you can do other things such as have frameworks for mobile development and gestures and all sorts of stuff. It's pretty amazing. So using some of these actually allows us to make an application that's written in HTML act more like a mobile app than a website. And so that's the idea of HTML5 that a lot of people talk about when it comes to mobile devices, is let's create HTML5 based applications instead of developing applications for each individual operating system. So there are a couple different ways. You can take the HTML5 and actually put it on the device itself, or you can access a website built in HTML5 with your mobile device, and the idea is that both would act the exact same. And if we take a look at it, people are browsing both the internet and using mobile apps for a fair amount of time each day. You can see that it's grown in both. It seems as though people used to access the web more than use mobile apps, but people are using mobile apps more than they are using the web now, but both have grown. Now, there are lots of new features of HTML5, new features for semantics and offline storage and device access and connectivity, multimedia, 3D graphics and effects, performance and integration with devices, and of course CSS3. The problem is that a lot of these things are not really what we think of as HTML5. These are all the different specs that are within it, but they're core technologies that we use, and the core technologies that we're always using in HTML5 that most people think of as HTML5 is HTML5 markup, CSS3 for the visual stuff, and JavaScript for the interaction. Now, to create a HTML5 app, there's a lot of different tools or skills involved. The JavaScript, HTML5, and CSS, and a lot of different things that go into it. I'm not going to be talking about this in depth, but it's just to note that those are the three technologies that really make this possible. Now, the benefits of web apps is that we're going to be able to use our existing web skills, HTML, CSS, JavaScript, and be able to create applications that can be delivered either through the web or as an application itself. Now, the other nice thing that's cool about HTML5 is that we can access many of the device features, especially when we use other third-party APIs like the JQTouch and other things like that allow us to integrate better with those features. Now, the problem with web apps has typically been slow performance, and that is kind of a major thing right now. If we take a look at it, there was even some documentation that showed that iOS applications that were web-based, HTML5 applications, and that were put on the phones were actually being throttled, meaning that they were not running as fast as applications through a website, which is kind of interesting. We actually found that web apps were throttled on iOS devices that were running 2.5 times more slowly when they were launched from the home screen rather than they were run using the mobile Safari browser. And I thought that was really, really interesting. Hopefully that will change. Now, there are lots of websites that you can find out about using HTML5 for mobile devices and making better applications, whether you deliver them on the device itself or through the web. HTML5 Rocks is another great website to find out more about that, and they have a whole section on mobile here which covers things like using mobile touch events and other things. So the question once again is, do we put the HTML5 on the site or on the device itself, or do we access a website using HTML5 or with the device that acts as an HTML5 app? And there's something to kind of bridge the gap there. And what is kind of bridging the gap is this new software that Adobe just purchased, and that's PhoneGap. And the idea is that you'll be able to use the same HTML5 application platform to be able to target anything you want. You can actually put it on a any mobile device or tablet or a website, and people can access the same sort of features, which is really kind of cool. Now, Dreamweaver is also making a major effort towards development for mobile. In fact, if you look back, Adobe has actually acquired PhoneGap as their own product now, and they'll be integrating it into more of their technologies, I'm sure. But they've already integrated some things. This right here is about viewport sizes and CSS3 media queries. Here, this is about the fact that you can actually build and emulate an application using Dreamweaver CS 5.5. This happens to use the jQuery mobile and PhoneGap in order to actually create an application for a mobile device, which can be installed. And I've created one for my college, which was kind of fun. Now, there are other tools that allow us to do similar types of things. AppMobi is an HTML5 development ecosystem that has a lot of stuff that helps developers develop very rich HTML5 applications and get them out there in pretty flexible ways. You can also see that they have a software development kit, which allows you to kind of test out your application and see what's going to work like. Now, there are some tricks that we can do to use to make our HTML5 application act more like a native application. Some of the things are, first, make it full screen, prevent the scaling of it so somebody can't scale the graphics. That way it takes you out of the experience somewhat. You want to prevent elastic scrolling, and that is basically fit your content to the page. You want to create a home screen icon. You can do that through a meta tag. And a splash screen, and that's another meta tag. That way, if they open up the application, it comes up with a splash screen first, acting like an application. You want to cache the application files. That means put them on the device itself, and that way you get the fastest performance. And most importantly, you want to detect touch and gesture events, because you want this HTML5 application to act like it is a native application. And people use touch events and gesture events as native application interactions. So that's something that we really want to make sure we do in our HTML5. Now, there are other tools for creating our applications for mobile devices, and some of them are HTML5 based and some of them are very different. If we take a look at what Apple has done, though, for a while they were actually blocking any other applications other than their own development toolkits that would allow you to create applications for iOS. Fortunately, this was stopped by the FTC, I think the Federal Trade Commission, that said, hey, you can't really do that. And so all of a sudden, all these new tools started cropping up, which allow you to create native applications for different devices using different types of code. This particular one, Appcelerator, seems to be one of the most common that I've seen out there, and this one uses JavaScript, and it maps these JavaScript APIs with methods and functions and all sorts of stuff to the actual native APIs and functions of the devices themselves, which means that when they're cross-compiled over to native code, they run like they're a native application. And the thing is, you can use the same code base, whether it is or you can use the same code base of JavaScript and target either an iOS application or an Android application. So it's very flexible. Now there are other tools like Corona SDK, and this one I think is very compelling because one of the things about it is that it uses a very simple version of scripting called Lua. Well, I say very simple compared to something like Objective-C. For example, display new image, my image JPEG, and put it at 00 is the same as all this code, which would be setting up the same thing in Objective-C. So I would rather code what's on the left instead of what's on the right, personally. Now this is some examples of what it looks like. This is Lua right here, and you can see it's a fairly easy language to wrap your head around if you're new to programming, and so that's one of the reasons I think that it has some real potential. Now there are other people who've said, hey, let's create a more simple user interaction language or application markup language, such as this one, AML, and it's very, very simple as well, but we'll see if it gets much traction. Now there are other applications that are being developed that are much more robust, that are very popular right now, and this is one of them. It's called Unity, and Unity allows you to output to so many different things. It allows you to output to iOS and Android, and of course, that you see here on the front, Flash as well. And so that's one of the things that I thought was interesting. You can also see they do Flash, the web player, iOS, Android, desktop, Wii, PlayStation, and Xbox, and that's full 3D immersive games with the same publishing platform. That is pretty darn cool. Now the last type of development we're going to talk about is Flash, Flex, and Air. Now Flash and Flex are two sort of different products. Flash is the integrated editor that we know with graphics and animation and all that, and also ActionScript 3. And Flex is the XML version of ActionScript 3, which is more of a application development framework. Now this all gets kind of put under the roof of the Adobe integrated runtime stuff, which Air is a way to package an application that gives it access to the device that it's on better than just Flash alone, which I think is really darn cool. So I know you've probably been waiting for it. Everybody's been talking about, you know, Flash versus HTML5 for a long time. So who's going to win and why? Now this right here is about HTML5 readiness. This is HTML5 and CSS3 readiness. And what I'm looking at here is the fact that SVG filters, 3D transforms, animations, and transitions, if you look at them, are still very, very early on in their adoption across different browsers on the internet. So in my opinion, HTML5 doesn't even come close to what Flash can do with animations and graphically. And that's going to be a problem for a while. If we also look at audio and video, that's the other thing that people have been saying, that HTML5 is going to rule the day when it comes to that. The problem with it is that we're dealing with codecs of video as well, and the codecs are not universally accepted across all the different browsers. The most common one right now on mobile is probably the H.264, and that's because mobile devices have processors that can process the H.264 video on the hardware of the device itself. So that's why you see it's become popular on the iPhone and Android devices themselves. But the problem is, whoops, we have all the other desktop versions of video that we have to be aware of as well. So the problem is people are still using Flash video on a lot of websites, and that's because Flash is much more ubiquitous across all of the different platforms. Now there are some problems obviously with Flash performance on mobile, and that's one of the things that we've been talking about. Now the reasons for this these problems that are really about the interaction with the devices themselves and the fact that Flash was kind of new on the mobile devices. And the numbers here I've seen have been improved upon with the more modern version of the Flash player, because now it can integrate with the device better. So these were some early tests a while ago, I think a year and a half ago, and it's definitely worth checking out. But what I find is that I don't necessarily agree with these numbers in real-life tests, and that's something I'll have to demonstrate at a later time. Now, the other stuff that I'm interested in are the performance of animation on the devices. And if we take a look at the frame rate of animations, you'll actually see that the Flash, this is 10.1, was faster than HTML Canvas in all tests. Also, it used half the battery life after 10 minutes doing the animation than HTML5 Canvas did. Now, this can be somewhat contributed to the fact that HTML5 Canvas animations are very early on in their life cycle, and maybe years to come things will improve greatly. Now, there's other animation benchmarks that show that this is also true. If we look at Flash 10 versus Canvas, HTML, and SVG, these are the three different ways to animate in HTML5, you'll see that Flash 10 beats all of them every single time. And I would suggest that you go and try out the Flash animations here that I have as an example to see if you can find those out. These are wonderful.net, and this is multiple phase flow. So definitely interesting to check out. Now, one of the things about Flash penetration is that the Flash has been enabled on many more devices, but you've seen that it's kind of ramped off a little bit, and probably the reason that it has ramped off here is because the other devices are iOS, most likely. Now, you've heard that Adobe has killed Flash on mobile devices, but it's very important to understand what they actually said. They said that they are not planning on releasing new versions of Flash for mobile browsers, but they are going to continue to work on Flash as an application development framework for iPad, iPhone, Android devices, and whatever else. And that is the ability to use ActionScript and Flash Builder and Flex framework in order to create rich internet applications or rich applications for the devices themselves. So this is Flash CS Professional 5.5, and here you can see I can create an Air application for Android, or Air for iOS, which is pretty cool. With the same software, I can create lots of different things. Now, there's lots of books coming out as well about development for Flash. And in my experience, I've actually done a little bit of development for Air for Android, and I found it absolutely the easiest way for me to use the graphic design skills that I like to use and the graphic design skills that I know will work and actually implement my own custom application. I found it much easier than any of the HTML5 methods when it comes to developing my own look and style, and that's very important. And the reason why this is important is because, in my opinion, the creative web and application development is ruled by designers, not just programmers. We want to design things that look good, and we want to use the design tools that we know. So, for example, if I'm an animator, I'm probably going to want to use Flash because I know how to animate in Flash, and it's much more difficult to animate in HTML5 at this point. However, tools are coming out for animation. We've got the Sencha Animator, we've got the Toolmoot Hype, and of course, oh, here's another one. This is, I don't even know how to say it, Sierra Creation Tools, but they've got something called Construct, which allows you to make games and animations, which is pretty cool. And then we have Adobe Edge, and this is their new animation tool for HTML5. And what I think is really going on is Adobe has pushed a lot of people from Flash into Adobe Edge in order to make sure that they keep a good market share in the development tools for HTML5, because they want the graphic designers to move over to their tools. And most graphic designers probably would if Adobe puts out some really good HTML5 development tools. Then I'm sure that a lot of designers will probably move over to them as they start to develop richer HTML5 websites and applications. Now, we can use some of the same stuff in Flash. We can actually use, this is Swiffy, which is a new Google application, or I guess It is a add-on to Flash where we can export right out of Flash to HTML5. Now the problem with that is that there's a lot of stuff that's not supported, like all the tween attributes and sound and all sorts of things that the HTML5 doesn't do. We're going to actually have to go and use other skills and develop that code, other methods other than just converting a Flash project to HTML5. My problem is that most of the HTML5 animations that I've seen are kind of simple right now compared to what we have in Flash. It's almost like we're going back to the original days of GIF animations like this, where we just have frame-by-frame animations, and that doesn't really excite me a whole lot. So what is going to happen with Flash? Flash is going to continue to develop on the desktop, and it's going to continue to develop on mobile devices as well. But when it comes to the desktop, it's probably true that the practical new web frameworks, HTML5, they're talking about, are probably going to kind of take over, and Flash will retreat to its proper place. And I totally agree with this, and that is to the niche areas and websites where it belongs and can really do amazing things. And all you have to do is go to thefwa.com, the Favorite Website Awards, and see some of the amazing Flash websites that are out there. And in my experience, I have not seen any HTML5 websites that are quite as compelling. We can take a look at some demos, though. I'm going to do that in a later tutorial. But if you want to take a look at some of the demos, I guess I have them hidden right now. Those demos, if I unhide those slides, agent8ball.com, blacktie.es. These are all HTML websites. We also have websites written in HTML5 that are particularly for mobile devices. I think is kind of nice. We have HTML5 applications, but the problem with these applications is that they don't work well on mobile devices, if at all. And we're also having problems with HTML5 animations on mobile devices. They don't work well either. They're very, very slow and very buggy about the interaction. Now, where HTML5 really is excelling is in video, in my opinion. But even then, there are some problems, which I'll have to talk about later. Now, take a look at some of the Flash projects that are out there, and you'll find that on a mobile device, such as my Android tablet, the EE Transformer Prime, or EE Transformer, these actually work compellingly well. Even though they were created for desktop. So, in my opinion, Flash is not dead on the internet, especially in the web browser, on mobile devices, and I'm hoping that it comes back, personally. So, I hope that you enjoyed this presentation. Please comment in YouTube if you have any questions about mobile development, and I hope you enjoyed. Thanks for watching.